this is Britt Caswell with another example video. In today's video, I'm covering example 3 from section 6-7 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to solve problems with geometric sequences. So in this problem, it says that a phone tree is when one person calls a certain number of people, and then those people each call the same number of people, and so on. In the fifth round of calls, 243 people were called. So this problem actually quite relies on us to rely on this picture, because they don't actually tell us in the word part of the problem the initial number of phone calls. Now if I look at this phone tree, I could see that the first person is calling 3 people, who is calling 3 people, who's calling 3 people, etc. Okay. So when I go to write my explicit definition, I'm going to start with a sub n is equal to, now remember I need my initial amount times my common ratio raised to the n minus 1 power. So my initial amount, or the initial number of people that we contacted, is 3, because you could see 1, 2, 3. Now, based off this image, I could tell you that the common ratio is also 3, because they're tripling the number of people here every single time. But when Savvas has it in the book, they're asking you to actually solve for that common ratio. So I'm going to act like I'm dumb and just kind of show you how to do it, okay? So the main part is right here. It says on the 5th round of calls, 243 people were called. So what they're asking me to do is plug in that 243 where a sub n is, and then where the n is here, put a 5. And now I need to solve for my r value. Now remember, in order to take a log to, oh, I don't need to take a log, I need to simplify. A log would have been if there's a variable up here. Silly logarithm section. Either way, the first thing we need to do, right, is we need to get rid of that 3. So from both sides of the equation, I'm going to divide by 3. So 243 divided by 3 is 81. And up here inside my exponent, 5 minus 1 is 4. So I have 81 is equal to r to the 4th. Now to counteract that r to the 4th, I'm going to take the 4th root of each side, which is where I'm getting my 3 for my common ratio. So this here is the explicit formula that will tell me how many people are called given a round number. Now from here, now they're asking if there's 8 people called, or sorry, if there's an 8 rounds of phone calls, they want us to figure out how many people are being called. So in essence, what they're asking us to do is to find a sub 8. So everywhere where there's an n in the equation, I'm replacing it with an 8. So a sub 8 here is 3 times 3 to the 7th power. And if you pop that bad boy into, you know, a graphing calculator or Desmo, something like that, you should get 6,561 people being called. So now that we're here, our book is now asking us to utilize this to talk about bacteria growth. So it says on the first day of the experiment, there were 9 bacteria in the petri dish. So that 9 bacteria is our a sub 1. On the 10th day, all right, so there's our n, there were 3 to the 20th bacteria in the dish. So that's our a sub n. They aren't telling us our common ratio, but they give us all the other information that we need to find it. So to start out with, we need to actually write out our equation, right? So I have a sub n equals my a sub 1, which is our initial value of 9, times r to the n minus 1. So this will be the equation that I'm slowly filling out. So now I need to solve for r. So this is where I put the 3 to the 20th is equal to r to the 10 minus 1. Now 9 is the same thing as 3 squared. And then 10 minus 1 is 9. So when I go to divide by that 3 squared, what that's going to do is that's going to allow me to just subtract my exponents. So I have 3 to the 18th is equal to r to the 9th. And so I'm going to go ahead and take the 9th root of each side. So the 9th root of 3 to the 18th is 3 squared, which means that our common ratio here is a 9. So now that I have our equation, now they're asking us to figure out how many bacteria there will be on the 7th day. So I am looking for a sub 7. So I have 9 times 9 to the 7 minus 1, which is 9 times 9 to the 6th. Now your textbook's kind of whack. They answer it as 3 to a certain power. I think that's weird. I'm gonna show you how to write it as 3 to the power so that you have the matching textbook answer. But that's strange. So see how on the 10th day they say it's 3 to the 20th bacteria? This is why they want it as 3 to a power, so that you could just compare the order of magnitude. So let's talk about this. So 9 is the same thing as 3 squared. So I have 3 squared times 3 squared to the 6th. So 3 squared times 3 to the 12th, which makes it 3 to the 14th power, which is what your book has. Unless I had looked at the book and gotten that correct answer, I would have thought to write whatever that big, hideous number is. But there we have it, guys. That is solving problems with geometric sequences. Until next time.